The unit circle is pretty useful in trigonometry, especially in dealing with the angles around the unit circle in terms of the 30, the 45, the 60, and those angles that are used an awful lot in trigonometric functions. The unit circle becomes useful because you can get all of the values that you need off of the unit circle, and that's really important when the question asks for the exact value of a trig function. So if you consider the unit circle x squared plus y squared equals 1, what are some of the ordered pairs around that circle? So if I sketch the circle, I know that if this is the unit circle, this radius is 1. The radius equals 1. This is the general equation of a circle. X squared plus y squared equals 1 squared. 1 squared, of course, is 1. So if this is 1, this ordered pair is over 1 up 0. What do you think this ordered pair is here? Over 0 up 1. So 0, 1. What about over here? I'll put an arrow here. That's negative 1, 0. And this one here, 0, negative 1. So I have ordered pairs for all of those. Again, remember the ordered pair has the x value first and the y value second. Okay, so let's put a value of 30 degrees in here, and suppose I want to know, if this is 30 degrees, what is the ordered pair that represents that arc length? Or on the edge of the circle, what is the ordered pair? So that when I draw the line from the center to that point on the edge of the circle, the degree measure is 30 degrees, measuring from the initial side, which is the positive x-axis. Okay? So how do I figure out what that value is? Well, you learned in geometry that you could drop a perpendicular, and now what do I have there? I hope you said a right triangle, and you're absolutely right. I have this right triangle here, 30 degrees. That's 90. Do you know what that angle is? 60, right? Okay, now, the only information we know at this point is this diagonal distance is 1. And I want to know, what is that ordered pair right there on the edge of the circle, so that when I can sketch a 30, I have that ordered pair. I know that this side is less than 1, you can tell in the picture, right? And usually in a right triangle, in fact always in a right triangle, the hypotenuse is the longest side. So what is the length of that side and that side? And at this point I don't know, and I don't have an instrument to measure, so how can I figure it out using some geometry? And then if I think about it a little bit more, hey, I could draw a 30-degree angle down on this side too, couldn't I? And if I do, I could drop a perpendicular. That is again 90, and this is 30. Do you know what this angle here is? It's 60. What's this angle? It's 60. What's this angle here? Hey, 30 and 30, that's 60. Let's take a look at that 60-degree triangle. Do you know what kind of triangle that is? All right. Remember, we started with a 30 here. We drew a perpendicular, so we knew that side is 1. We knew that was 60. Then I drew another 30 down here, right? So that's 60. That again is 90. Do you know what kind of triangle I have? Yeah, it's an equilateral triangle. I hope you knew that. So what's this side here? Why, that's 1. What's this whole side here? Why, that's 1. Now, I have some clues to these distances. Any thoughts on what it would be? Well, we know that whatever this is, it's equal to this, correct? So those are similar triangles. Well, if the whole thing is 1, each part has to be half of 1. So that's got to be a half. And so does this. Half plus a half is 1. Well, we're part way there for getting that ordered pair, x, y, right? I don't know how far I go over, but I know I go up a half. So let's put that in there, the upper part, a half. Now, how can I figure this part out? Well, let's think of that triangle. I've got 1 here. I've got a half here. I know that's a 90. I don't know this. Do you know an equation we could use? A squared plus b squared equals c squared. So x squared plus a half squared equals 1 squared. X squared plus a fourth equals 1. Subtract a fourth from each side. X squared equals 3/4. Let's take the square root of both sides. And remember, we're going to use just the positive square root because we're talking distance. So x equals square root of 3 over square root of 4. How about square root of 3 over 2? There we go. So this distance, the bottom distance, root 3 over 2. How about that? We figured out some of these distances on the unit circle. So that means that the over distance from 0 over for the bottom of this right triangle is root 3 over 2. Now, an interesting thing about this, so now I know this ordered pair, root 3 over 2, 1/2. Well, over root 3 over 2, up a half. Now, I could figure this out. I could use similar triangles to get all of these values around here. I could get the 45, I could get the 60, and then over here I can get the 45, the 30, the 60, the 45 coming up this way. Of course, I'm going to name them going all the way around counterclockwise. But all these ordered pairs are going to get repeated all the way around. The interesting thing about this is this ordered pair, we called it XY. It can also be called cosine theta, sine theta. You know some stuff about trig functions, right? So getting the trig functions off of this unit circle, so we have this one ordered pair for 30. Remember, it's over root 3 over 2 up a half. Well, I can do all the trig functions from that. So the sine of 30 in this picture is opposite over hypotenuse. Opposite side, that's 1/2, right? Is 1/2 over 1. 1/2 over 1 is 1/2, so the sine of 30 is 1/2. What's the cosine of 30? It's adjacent over hypotenuse. What's the length of the adjacent side? Root 3 over 2 all over 1, which is root 3 over 2. What's the tangent of that 30-degree angle? It's opposite over adjacent. 1/2 over root 3 over 2, which is, what happens when you do that? 1/2 divided by root 3 over 2 times 2 over root 3, which ends up being 1 over root 3, or root 3 over 3. With me there? And then the cosecant, secant, and cotangent are reciprocals of these functions, so cosecant is 2 over 1, and so on. I know you can do that because we did the trig function. Okay, so you ready for the real tricky part? We're not going to be doing sine of 30. We're going to be doing the sine of pi over 6. Uh-oh, what's pi over 6? It's the same thing as 30. So all of these values that we are so comfortable writing degrees, we're going to write in radians. The trig functions are still the same. So what's the sine of pi over 6? It's 1/2, right? What's the cosine of pi over 6? It's root 3 over 2. And the tangent pi over 6 is root 3 over 3 in radical form. These are exact values. I don't want you to use decimals. And what happens when I have a 30 degree over here? That's really 150 degrees if I'm measuring from this coordinate, right? Oh, but I told you we're going to do radians, right? So what's 150 in radians? Multiply by pi over 180, right? And you know how to do that, I hope. So 5 pi over 6. Now, how do I do the 6 trig functions of 5 pi over 6? All right, well, let's think about that right triangle again. Over how many? Negative, this time, root 3 over 2. I want positive root 3 over 2. This time it's negative root 3 over 2. Up, positive a half or negative a half? Up, positive a half. So that ordered pair for 5 pi over 6 is, the ordered pair is over negative root 3 over 2 up a half. What are the trig functions for that? Well, remember, they can be written in this ordered pair form. So this is the cosine and this is the sine. So what's the sine of 5 pi over 6? It's 1/2. What's the cosine of 5 pi over 6? It's negative root 3 over 2. What's the tangent of 5 pi over 6? It's negative, and simplify it, root 3 over 3. All right? We can put these ordered pairs all the way around. The signs on the ordered pairs, be careful. Make sure they correspond to being in the appropriate quadrant. But with the unit circle and the ordered pairs for the 30, the 45, and the 60, all the way around, if you fill in that unit circle with ordered pairs, having the signs proper, remember, if I have an ordered pair in this quadrant, it's positive in the first one, negative there. If I have ordered pairs in this quadrant, they're both negative. In this quadrant, it's negative, positive. In the first quadrant, it's positive, positive. So signs on those ordered pairs become important because the sine, cosine, and tangent of the values are positive and negative, indicating which quadrant they are in. Good luck with this assignment.